Today, we are diving right into one of the coolest things about Cisco's application-centric infrastructure, or ACI for short. It's automated fabric discovery. I mean, think back to the old days, right? You're manually configuring every single switch, every link, juggling spreadsheets. It's just asking for trouble. But what if a system could do all of that heavy lifting for you? Well, that's exactly what we're going to see, how a pile of boxes literally transforms itself into a fully functional, intelligent network fabric. It's pretty amazing stuff. So this right here, this is the end game. What we're looking at is that classic leaf spine topology. And right at the heart of it, you've got a cluster of APIC controllers. That's the central brain of the whole operation. It looks so clean, it's super scalable, and it's incredibly powerful. But the real question is, how do you get from a stack of disconnected hardware to this fully meshed, policy-driven fabric? That's the magic we're going to unpack today. We're going to break it down into 5 clear stages. First up, we'll look at the core protocols that make this whole thing possible. Then we'll talk about laying the right foundation. After that, we'll witness that very first handshake between devices. Then we'll watch the entire fabric build itself out. And finally, we'll see how the controllers find each other to form a super resilient cluster. Let's get into it.
So, what's the secret sauce behind all this automation? Well, it's not actually magic. It's just a really, really clever combination of 2 networking protocols that you probably already know, working perfectly together. And really, it all boils down to these 2. First, you've got LLDP. You can think of LLDP as the fabric's eyes and ears. It's how one switch looks at the device on the other end of the cable and says, "Hey, who are you?" It's all about neighbor discovery. And then, once they know who their neighbors are, DHCP steps in to handle the paperwork. It assigns all the internal IP addresses that these devices need to actually start talking to each other. It's these 2, working in concert, that get rid of almost all that tedious manual setup. All right, so before we just unleashed all this cool automation, we do have to do a little bit of prep work. And I can't stress this enough. Getting this foundation right is absolutely crucial for the whole discovery process to work. And that brings us to the rules of cabling. The ACI discovery logic is smart, but it relies on a very specific physical topology. Leaves can only talk to spines. Spines can only talk to leaves. And the apex, the brains, they have to plug into the leaves. You absolutely cannot have leaf-to-leaf or spine-to-spine connections. If you mess this up, the discovery logic just breaks. So that physical discipline from the get-go is key. Now, this is where it all officially kicks off. An admin grabs a console cable, plugs into that very first APIC, and runs a simple setup script. You can see on the screen it's just a series of questions. This is where you give the fabric its identity. What's its name, how many controllers are we expecting, and maybe most importantly, what internal IP address range is it going to use? And that question leads us to this critical concept, the TEP address pool. TEP stands for tunnel endpoint, and you really can think of this IP pool as the fabric's own private nervous system. It's the address space used for all that internal communication between the switches and the apex. You set this up once in that initial script, and here's the kicker. You can't change it later without completely rebuilding the fabric. So you've got to make sure you pick an IP block that's not used anywhere else and is big enough for the future. Okay, foundation's laid. The rules are set. Now we get to the really cool part. Let's zoom way in and watch that very first conversation that happens between our brand new APIC and the first leaf switch that powers on. This little diagram here, it perfectly captures that first hello. On the left, you've got the APIC, all configured and ready to go. And on the right, you have a totally blank slate leaf switch. What we're about to see is the precise dance of protocols that brings this new switch into the family. So let's just walk through it. First, using LLDP, the APIC and the switch literally just see each other on the wire. At that point, the switch pops up inside the APIC's graphical interface, just waiting for an admin to say, "Yep, I know you, come on in." The admin gives it a nome and a node ID, and that's the official registration. As soon as that happens, the APIC's built-in DHCP server springs into action and hands the switch its own unique TEP address from that pool we just talked about. And now that it has an IP, they can build a secure tunnel and start exchanging policies. Just like that, the switch is a fully managed part of the fabric. So once that first switch is online, it basically becomes a stepping stone. The discovery process doesn't just stop, it explodes outwards from that one initial connection in this amazing cascading effect that brings the whole fabric to life. This diagram here shows you that whole picture, how the fabric really builds out. We already covered step 1, the APIC setup, and step 2, where we discovered that first leaf. Now, we're going to trace how that one little link becomes the catalyst for discovering every other switch in the entire network. It's really just a beautiful chain reaction. That first leaf, which is now fully managed, it uses LLDP to find the spine switches it's plugged into. Then those spines pop up in the APIC, waiting for you to register them. Once the spines get their TEEP addresses, what do? They go out and discover all the other leaf switches they're connected to. And while all of this is happening, in the background, ACI is automatically building an ISIS routing domain. Don't worry too much about that part. It's just the underlying glue that makes sure all these TEEP addresses can talk to each other.
And here's what it actually looks like from your point of view as the administrator. Inside the APIC interface, under the Fabric Membership section, you've got this tab called Nodes Pending Registration. And as this cascade is happening, new switches just appear here, one by one, identified by their serial number. This is such a critical security step, by the way. Nothing gets to join the Fabric until you, the admin, explicitly click on it, give it an ID and a name, and hit register.
Okay, so all the switches are in, the body of the Fabric is built, but what about the brain? The last piece of the puzzle is making sure all the AP controllers find each other and form that synchronized, highly available cluster. And this is where a really cool concept called the appliance vector, or AV, comes into play. Just think of the AV as the Fabric's unique DNA. When that first APIC brought up the first switch, it passed along this little bundle of information: the Fabric name, the tip pool, how many APICs to expect. Every switch in the Fabric holds on to this AV, and it basically acts as a security bouncer at the door to make sure no rogue or misconfigured APIC can accidentally join your cluster and wreck everything. So here's how that works. Let's say a leaf switch discovers a second APIC that you've just plugged into it. It sees it via LLDP. But before it does anything else, that leaf acts as a little security checkpoint. It compares the info it's getting from this new APIC to the appliance vector DNA it's already storing. If the Fabric name, the TEP range, if it all matches up, the leaf knows it's legit, and only then does it act as a trusted introducer. It tells the first APIC, hey, I found APIC number 2, and he's cool, he checks out. And at that point, the two APICs can start talking directly, synchronizing their databases and forming that all-important cluster. And of course, you're going to want to verify that everything worked as expected. You've got a couple of ways to do this. For the command line folks, you can SSH into an APIC and run the AciDAG AV read command to see all the details. Or, way easier, you can just look at the main dashboard in the GUI. You've got that controller status panel, and what you're looking for is for all your APICs to show a health state of fully fit. That means they're all synchronized and happy. And this is the finish line. This is your proof of success. When you go back to that Fabric Membership tab and look at registered nodes, you see this complete inventory of your brand new Fabric. Every leaf, every spine, they all have a unique node ID, a name you gave them, an IP from that TEP pool, and a beautiful status of active. What started with just a few questions in a setup script has now become a fully discovered, fully connected operational network fabric. So all that automated heavy lifting, it's done. The Fabric exists now as this perfect blank canvas, just waiting for you to tell it what to do. The physical underlay is built. The focus now totally shifts to the logical overlay, to policy. So the real question is, with this incredibly powerful foundation now in place, what are you going to build first?